Hello everyone, you're welcome to this physics lecture. In today's video, we'll be starting an important topic in mechanics known as kinematics. Kinematics is one of the foundational areas of physics, and understanding it properly will make many other topics in mechanics much easier for you, especially acceleration, equations of motion, and motion graphs. So, let's begin from the basics. Mechanics is a major branch of physics that deals with the motion of bodies and the forces responsible for producing that motion. In mechanics, we are interested in questions such as: how do objects move? How fast are they moving? How does their motion change with time? And what causes that motion? To answer these questions, mechanics is broadly divided into two major groups: kinematics and dynamics. Let's clearly understand the difference. Kinematics is the study of motion of objects without reference to the forces responsible for the motion. In other words, in kinematics, we describe how an object moves, but we do not worry about why it moves. On the other hand, dynamics deals with motion together with the forces that cause the motion. So, if you are analyzing displacement, speed, velocity, or acceleration without discussing forces, you are working in kinematics. In this course, our discussion is restricted to kinematics only. That means we will describe motion quantitatively, using equations and graphs, without considering the forces responsible for that motion. In addition, we will focus on one-dimensional motion, which is motion along a straight line. This is very important because one-dimensional motion forms the foundation for understanding more complex motion later. One-dimensional motion refers to motion along a single straight line, which we usually take as the x-axis. For this type of motion, only two possible directions exist: the positive direction, usually written as plus x, the negative direction, written as minus x. A simple example of one-dimensional motion is a vehicle moving along a straight road. Since the vehicle moves only forward or backward along the road, its motion can be described using a single axis. To describe motion quantitatively in kinematics, we make use of certain physical quantities. These include displacement, average speed, velocity, acceleration. These parameters help us answer three important questions. How far does an object move? How fast does it move? How does its motion change with time? In this video, we will carefully explain displacement, average speed, and velocity. Let's consider the first parameter: displacement. Displacement is defined as the change in position of a particle in a specified direction. This means displacement tells us how far an object has moved from its initial position to its final position, taking direction into account. Let's consider a simple situation. Suppose a car is at position x1 at time t1, and later moves to position x2 at time t2. The displacement of the car is given by the expression x2 minus x1. Here, x2 represents the final position, and x1 represents the initial position. This formula applies whether the object is moving forward or backward along the x-axis. Now, let's consider motion along the negative x-axis. If the car is moving in the negative direction, the positions x1 and x2 will carry negative signs. In that case, displacement becomes minus x1 minus bracket minus x2, which implies that displacement equals x2 minus x1. This clearly shows that displacement depends only on the initial and final positions, as well as the direction of motion, and not on the path taken. It is very important not to confuse distance with displacement, because distance is the total length of the path traveled by an object. It is a scalar quantity, meaning it has magnitude only. Displacement is the shortest straight line change in position in a specified direction, and it is a vector quantity. Let's consider another parameter: average speed. The average speed of a particle is defined as the ratio of the total distance traveled to the total time taken. Mathematically, average speed equals total distance traveled divided by total time taken. For example, If a car covers a certain total distance within a given time interval, we calculate the average speed by dividing the total distance by the total time. It does not matter how the car moved during the journey. What matters is only the total distance and total time. Velocity. Velocity is defined as the rate of change of displacement with respect to time. Unlike speed, velocity tells us how fast an object moves and in which direction it moves. If a car moves from position x1 at time t1 to position x2 at time t2, the average velocity is given by x2 minus x1 divided by t2 minus t1. Since displacement appears in the formula, velocity automatically includes direction. That is why velocity is a vector quantity. In this video, we have introduced kinematics and explained motion in one dimension. We carefully discussed displacement, average speed, velocity, the difference between scalar and vector quantities. A proper understanding of these concepts forms the foundation of kinematics and prepares you for the study of acceleration, equations of motion, and motion graphs, which we will cover in subsequent lessons. Thank you for watching. See you in the next class.